So section 2 in this chapter deals with another process that we can use to solve systems of equations. And there are a lot of processes that you can use to solve a system of equations, but this is the number 3 process that we can use to solve a system of equations. And actually what we're going to do first is talk about this process called elimination, and we're going to deal with it with 2 equations, and we're going to jump into 3 equations a little bit later. But what I need to talk about are a few specific properties that you need to take note of. Okay, the first one is that anytime you add 2 equations in a system, okay, and I should put or subtract, so one or the other. What we get is a new equation. So the new equation that we get is also in the system. Okay, so we're going to use this property to use this process of elimination, but we need to make sure that anytime you add or subtract 2 equations, the resulting process gives you a new equation that's in the system. My second note is the fact that you can multiply or divide any equation by any number in a system. Okay. You can multiply an equation by any number that you choose, okay, as long as you multiply everything. You must multiply every term. That's a given. You have to multiply every term if this is going to work. So the question is, how are we going to take these 2 things and apply it to something that is using this process? So you can see here we have this system, okay, and we have a couple options that we could use. We could try and graph this. Okay, we could try and graph this, which means we could solve for y. We could try that. Okay, but none of this is going to be very clean, so we're not going to do that. We could try substitution. We could try that as well, but again, take a while. So here's what I'm going to do. I'm going to use both properties that I just got done talking about, and I'm going to create something that allows us to have a much more simple equation to solve. Now, what I was saying before is that we can add or subtract these 2 equations, right? And what that means is that if I add this equation to the first and the second ones together, I get 5x plus 9y equals 1. And this is another equation that I could add to this system. But that doesn't help us because we already have 2 equations, 2 variables. So that really doesn't help us. So we need to think of something else that we can use to do this. So that first property was saying I can add or subtract 2 equations. But now here's where the second property comes in. I'm going to make it so it's more convenient to add these two things together. To do that, I'm going to multiply both of these equations by something, and you'll see why in just a second. I'm going to multiply this first one by 2. So I'm left with 6x plus 8y equals 4. I'm going to multiply the second one by something as well, but it's perfectly legal to multiply everything by some number. Now I'm going to multiply the second one by a 3. And not just a 3, a negative 3. So this one becomes a negative 6x. This becomes a negative 15y. And that's going to equal positive 3. So I multiplied everything by a negative 3 here and a positive 2 here. Now you might ask, well, why did creating two new equations help us? If you look particularly at this one here and this one here, notice that they are opposites of each other. They are opposites. And anytime you have any equation with opposites, when you add them, they are going to cancel each other out. So if I add these two things together, I'm going to add this whole equation, so these two eliminate. That's why it's called elimination, because these variables eliminate. So what I'm left with is negative 7y equals 7. To solve this, I'm going to divide by a negative 7. And I'm left with y equals negative 1. So I eliminated this variable, I added down these columns, and I was left with one equation, one variable. So I have the first of my variables for this system. Now I got to do something about trying to find x. Now I have two options. I could plug this in. I could do that. Or I could eliminate again. Now I'm going to show you the elimination process again and just how you eliminate the exact same thing, but this time a different variable. So I'm going to eliminate now. I eliminated the y's before. Now I'm going to eliminate the x's. So I'm going to take this first equation and times it by 5. So I get 15x plus 20y equals 10. And I'm going to take this second equation and multiply by 4, and not just a 4, a negative 4. And I'm going to get 8x minus 20y equals, excuse me, it's a negative 8x minus 20y equals a positive 4. So what I'm left with, see, notice again, these are opposites of each other. So these are going to eliminate. So what I'm left with is 7x equals 14. So I divide by 7. I get x is equal to 2. So my y value for this is 2. Now I could have plugged this in up here into one of those equations and still gotten an x value of 2. But I'm showing you how the elimination process works. Now I'm going to talk about another one. Same idea. You want to get one of the variables to eliminate. It's really a choice for you. It doesn't matter which one you choose. So I'm going to just pick one. I'm going to eliminate the x variables. So I'm going to eliminate the x variables. Notice that this is already a 4, so I'm going to get these to match up by timesing this by a negative 2. Now I picked negative 2 because that makes this a negative 4x. This becomes a positive 2y, and that's going to equal a negative 6. then here it's going to be 4x. I don't need to multiply the second one because it's already a positive 4x. So if I add these two things together, this eliminates. But we also run into another problem. Okay, the problem that we run into is that this now eliminates, and this eliminates, because the opposites of anything eliminate when you add them. So what are we left with? Well, if everything eliminates, on one side I have nothing left. If everything eliminates on the other side, I have nothing left on the other side. So how can we solve something if all we're left with are two zeros? Well, what that means is that we have a true statement. This is a true statement. So what we have is the fact that since this is true, we can say that this is the same line. That's all we can say. So there are an infinite number of solutions. They're the same line, so there's an infinite number of solutions. Now, in the next section, I'm going to talk about these particular problems, how you go about solving them.